Welcome to this AI-generated deep dive recap of the session on building secure AI agents using Microsoft Entra External ID. We'll explore the key concepts, architecture, and security principles that enable safe and scalable AI-driven applications today. In this session, you learned how integrating AI into identity and access management opens exciting opportunities to personalize user experiences and secure your applications at scale. Keep in mind, there's a rich demo included in the full session video that showcases the practical implementation of these ideas using Microsoft Entra External ID and AI agents, so I highly encourage you to check it out to see all the pieces in action. We started with an overview of the agenda, covering 6 key areas: the initial introduction to AI and identity, exploring challenges around consumer identity management, then moving into a live demo of the AI agent, followed by a deep dive into the code powering it, and finishing with practical takeaways to apply right away. The session balanced technical depth with real-world examples to help you understand how to build secure AI-powered applications. Generative AI adoption is skyrocketing across industries, creating huge opportunities but also introducing new security risks. According to Microsoft surveys, nearly 60% of organizations anticipate a rise in AI-connected security incidents. This makes it crucial to design security from the ground up, especially around identity management. Tools like Azure AI Foundry and SDKs make it easier to build AI agents, but without a solid identity architecture, risks multiply. In the session demo, zero trust principles were central. Microsoft Entra External ID, a cutting-edge customer identity platform, was used to secure millions of accounts while allowing full customization for consumer experiences. This balance of scalability, security, and user-centric control is what makes Entra External ID a powerful choice for AI agent applications. Before the demo, the architecture was explained. A user interacts with a web app here, the Good Group grocery app that relies on Entra External ID for authentication. Behind the scenes, an AI agent API orchestrates calls to back-end resource APIs managing products, shopping carts, and checkout, all while enforcing strict identity-based security. A key point emphasized was future-proofing your applications by building strong identity foundations early on. Doing so not only protects against unauthorized access, but also reduces critical production issues, leading to a more stable and scalable system. This proactive approach minimizes firefighting and frees developers to innovate and roll out new features seamlessly as AI capabilities evolve. Choosing the right authentication flow is critical for securing app interactions. There are several flows: authorization code, client credentials, and on behalf of, each suited to different scenarios like user-facing apps, server-to-server communications, or acting on a user's behalf. Proper role-based access control follows, using app roles or security groups to assign precise permissions, ensuring users get only the access they need. Additionally, managing user friction is vital. Features like incremental consent let users approve permissions gradually. Admin consent handles complex workflows, and conditional access policies balance security with user experience. While these details may sound complex, the demo later illustrated how all these security concepts work together to provide smooth interactions without compromising safety. Microsoft Entra External ID is a powerful customer identity and access management solution built on trusted Microsoft platforms. It acts as a digital front door, offering scalability, security, and a highly customizable user experience powered by machine learning models trained on billions of user interactions. Developers benefit from seamless integration tools like Visual Studio Code and Copilot, enabling rapid setup and flexible evolution to meet your needs. The session laid out the demo architecture clearly. Users sign into the web app via Entra External ID, which handles authentication and directs secure tokens to the app. The AI Agent API acts as the brain, orchestrating calls to the resource API that manages the actual data, products, carts, and checkout. His separation ensures robust security, scalability, and data protection. The demo featured a dual view: the Woodgrove Groceries web app front-end where users interact, and a back-end telemetry dashboard showing real-time API token validations. This live insight demonstrated the secure flow of identity and data, a core aspect of building trustworthy AI applications. The live demo focused on the Woodgrove Groceries shopping agent managing the full customer journey, from user sign-up with details like date of birth and dietary restrictions for personalization, to cart management and checkout with built-in security features. For example, age gating prevented purchasing restricted items like alcohol for underage users, while high-value cards triggered multi-factor authentication for extra security. Role-based access was also demonstrated. Switching to an administrator role enabled product management actions like price updates. The demo highlighted how zero-trust principles and external identity integration come together for a secure, intelligent shopping experience. Watching the full demo in the session video is highly recommended to see all these capabilities in action. The authentication flow is detailed in the demo as well. Users start at the web application, which redirects to Entra External ID for sign-in, then returns tokens to the browser. The browser uses these tokens to connect securely to the agent API with limited scope. The agent API then employs an on behalf of flow, exchanging the user's token for one scope to the resource API, ensuring layered security and that the user never accesses backend APIs directly. Token validation and enforcement of business rules occur at every API layer, following zero-trust design principles. 3 app registrations in Entra External ID, 1 each for the web app. Agent API and Resource API simplify token management, keeping access tightly controlled and permissioned. Exploring this flow in the full session demo offers a valuable understanding of implementing secure API interactions. We then went deeper into app registrations within Entra External ID, where 3 confidential clients represent the Resource API, Agent API, and Web App. Each stores secrets securely and uses appropriate flows. The Web App with authorization code flow and delegated permissions plus MFA, the Agent API with on behalf of flow, and the Resource API enforcing role-based access with fine-grained scopes. Admin consent was applied to reduce user prompts, improving the experience. The Resource API controls permissions carefully, exposing scopes like products.read and checkout, and uses application roles to enforce least privilege. The Agent API communicates with the Resource API using its own scope, chat. Use under admin consent. Each component validates tokens and policies rigorously, including MFA status claims, ensuring security adheres to zero-trust principles. Telemetry and monitoring are integrated to detect token failures and maintain security health, while avoiding revealing sensitive info and errors. This layered approach ensures security without sacrificing usability, a critical balance for AI applications that require identity-centric protections. The demo and code walkthroughs provide full insight into how this architecture works in practice. Now we examine the core of the agent's code with getUserInfo tool, a component that extracts identity claims and user roles from access tokens into a JSON object for the AI agent to consume. This identity awareness allows personalization and enforces business logic based on roles, such as greeting users by name or tailoring actions for product managers versus regular shoppers. The development journey started with GitHub Copilot generating an OpenAPI YAML file representing the shopping cart scenario, which automated backend controller creation, speeding development dramatically. This YAML file outlines API endpoints for products, carts, and checkout, and also powers the agent's knowledge by loading it into a vector database enabling API calls, an elegant way to connect the AI agent to existing backend services. The agent's behavior is defined by system prompts instructing it how to use tools like getUserInfo tool, HTTP clients, and even system time checks to validate age and MFA status. This comprehensive logic ensures the agent enforces policies like age gating and multi-factor authentication transparently and smartly during interactions, rejecting restricted items or requiring step-up verification for large purchases. Next, we looked at the custom API function tool that empowers the agent to make HTTP calls specifying method, URI, payload, and appropriate authorization scopes. This ensures all generated API requests are complete, valid, and securely authorized, enabling safe integration with various APIs. This flexibility is essential to support diverse backend services while maintaining strict security boundaries. The Agent API uses system prompts to personalize every user interaction. It dynamically fetches user info from tokens to craft responses tailored to roles and permissions. For example, product managers get targeted help with CRUD operations on products, while regular users focus on shopping and recipes. This role-based customization ensures a consistent, secure, and user-friendly experience tailored to each user's needs. API documentation is key to smooth integration. It follows the OpenAPI 3.0 Swagger YAML standard, clearly defining endpoints, methods, parameters, and schemas. Using embedded tools like file search function name simplifies looking up details without sifting through clutter. The RESTful API design maintains consistency and reduces errors, making it easier for developers and the AI agent alike to interact with backend services reliably. Multi-factor authentication, MFA validation, is enforced at multiple layers for robust security. The Resource API checks embedded token claims to confirm MFA completion during sensitive operations like checkout on high-value carts. It also verifies roles explicitly for actions like product creation, ensuring only authorized users can perform privileged operations. These layered checks integrate step-up authentication seamlessly into the user experience, following zero trust principles thoroughly. Focusing on the Resource API, the Create Product endpoint illustrates strict role and scope enforcement using attributes like required scope or app permission and require app role. This defense-in-depth approach ensures only users with the right permissions, such as the products.writeScope and product manager role, can create products. Invalid data is rejected immediately to maintain integrity. This is a prime example of applying least privilege and layered security to protect sensitive backend operations effectively. Looking ahead, combining AI innovation with robust identity frameworks is critical. Azure AI Foundry offers a rich model catalog from foundational to industry-specific AI models accessible through developer tools like Copilot Studio and Visual Studio. However, solid identity architecture remains the foundation for secure AI applications. Microsoft's Secure Future Initiative (SFI) reports provide valuable insights into implementing zero trust at scale. The core zero trust principles, verify explicitly, use least privileged access, and assume breach, are guiding stars for building smarter, more secure AI-enabled applications. Learning from these principles and best practices helps future-proof your solutions against emerging threats and complexities. To wrap up, there are excellent resources to help you dive deeper. The Woodgrove demo website offers a live environment showcasing the concepts we discussed. The Microsoft Secure Future Initiative is a great place to understand scalable zero trust implementations. And the public GitHub repository contains all the session's code examples to explore and build upon. These resources empower you to confidently develop secure AI applications grounded in strong identity foundations. Thanks for joining this recap, and don't forget to watch the full session video to see the live demos and code walkthroughs in detail.